All right, so the last thing we left off doing, we're in our note sheet here. And if you haven't already done so, the top note here, I'm going to rename as inequalities. Oh, I think I already have that in another section. So I'm going to call it all right, so I've got my inequalities here. And whoops, I'm going to go inside there. And just to show you, the last thing we were doing were the linear systems. Remember, we were doing the shading thing. Okay, we did that on Delta Math also. And so the next thing that we're going to do, and this is going to be our last thing, are quadratic inequalities. So here we go. Quadratic inequalities. And, quadratic means x squared, right? It's got an x squared in it. And an inequality means it's going to be a less than or greater than or equal to, okay, but not just equal to. So this would be an example of a quadratic inequality. Let's say we had x squared plus 6x minus 16 is less than 0. All right, so it's quadratic because of this. It's an inequality because of that. And what we're trying to do is just find the numbers that would make this true. There's a number of numbers. So it's going to be, our answer is going to be like a section of numbers. So first thing we do is just kind of treat it like an equation. And so I'm going to do that, that gives us our key points. I'm going to factor this. It looks like that's factorable pretty easily here. So that's going to be what, x plus 8 times x minus 2. Now, make sure that you check my work. All right, but that's looking okay. And the things that make that equal to 0, those are the key points. So that means we have key points at -8 and +2. So then we just put those key points on a number line. And that splits the number line into 3 regions. So let's say -8 is over here, +2 is over here. And we want to test each region. We have to test this region here to the left of -8, this region, the one in between them, and then this region to the right of +2. What's nice is if one number works, they all work, kind of like we were saying with the other inequalities, the linear inequality. So I'm going to take any number to the left of -8 and plug it in and see if it makes this a true statement. So I'm going to pick a number way to the left of -8, like -1 million. I make it extreme because I only care if it's positive or negative. If I plug -1 million in for x there, that's going to be a negative number. If -1 million plus 8 is negative. And -1 million minus 2 is also negative. And a negative times a negative is a positive. So that means that everything in that region is going to give me positive answers. The reason why that's significant is because positive numbers are bigger than 0. That's actually not going to be my solution set because I want stuff that's less than 0. So I know that that's going to be positive, anything to the left of that -8. Now I'll pick a number in between -8 and 2. So 0 is always a nice number, right? So 0 plus 8 is a positive number, of course, because it's 8. And 0 minus 2 is negative, because it's negative 2. When you multiply a positive times a negative, you get a negative number. And then last, I will test my last region. Oops. My last region, which is the region on the right over here. So something bigger than positive 2, like a million. A million plus 8 is positive. A million minus 2 is positive. A positive times positive is positive. And so now that I've tested all my regions, I want to know which region gives answers less than 0, namely negative stuff. So it's that region in between. So our answer is that region. So it is from -8 to 2. All right, so let me give you guys another example. So I didn't see I didn't see any questions pop up. So I'm kind of assuming you guys are getting it. It looks like you guys in class here are doing okay. So I'll do another quick one here. Let's say we had x squared minus 13x plus 40 is greater than or equal to 0. All right, again, we're going to try and factor this. If it doesn't factor, we could use quadratic formula, but I think this one does factor. Factors of 40, that would give you 13, would be like 8 to 5, right? So that's going to be x minus 8 times x minus 5. So that means my key points are 8 and 5. All right, so let me draw the number line here so that I just have a visual for my regions. Let's say 5 is here and 8 is here. I need to test the left region, the middle region, and the right region. So if I plug in a number less than 5, so I'll plug in 0. 0 minus 8 is negative. And 0 minus 5 is negative. So I multiply negative times negative, I get a positive. Then I'll plug in a number between 5 and 8. So I'll take 6. Now you can do 6 or 7. Whole numbers, of course, would be easier. So 6 minus 8 is a negative. 6 minus 5 is a positive. Negative times positive will be negative. And then I'll plug in something to the right. So like a million, that's going to be positive. That's going to be positive. And so then we get positive when we multiply those two. So be careful with our inequality. We want to know what make values greater than or equal to 0. Well, greater than or equal to 0 would be things that are positive. So we have 2 areas where our answers are. Okay, they are here and here. So our solution then is going to be, for this part, it is from negative infinity to 5, bracket, because it is inclusive of 5, because that makes it equal to, we want to keep the borders in this case. And then bracket from 8 to infinity. That's this region. All right, any questions on those guys? The only way these really get harder, and you don't even need to write this down. I'm just going to give you a quick example just to show you where it would be a little more difficult. So again, you don't have to write this down. I might just whip through it kind of quickly. But if we had something like 2x squared minus 27x is less than 7x minus 140. Well, the only difference between that and this is that it doesn't have 0 on one side. So all we do is move everything to one side. So I'll like move the 7x over. I'll move the 140 over. So I'm going to get 2x squared minus, that's going to be minus 34x, and then plus 140. And now is less than 0, and now it's similar to the problem above. The factoring is a little harder. I notice all of these are even, so I could divide everything by 2, giving me x squared minus 17x plus 70 is less than 0. And now it's really looking like the problems above, because I could factor that into x minus 7 times x minus 10 to get my key points. And I know that I'm going kind of quickly, so I'll leave this up here for you guys if you want to write down, but you don't have to. I'm just doing the same process as in our last problem. So I have my area from 7 to 10. And if I plug in 0, that's going to be negative. That's going to be negative. Therefore, that will be positive. If I plug in 8, that will be positive. That will be negative. Therefore, that will be negative. And if I plug in 1,000,000, that will be positive. That will be positive. Therefore, that will be positive. And so since my solution, we want it to be less than, that means we want all of this stuff because it's negative, it's less than 0. And so our answer is from 7 to 10. Okay, so the only difference between those last two examples were we just had to do a little algebra here to make it look like that guy. All right, we think we got it?